Hi everyone, in this video we're going to talk about the last type of transformation that you know about, and that's translations. We're only going to talk about the horizontal type because vertical just shifts up and down by adding onto the end. That's pretty easy to understand. So let's just talk about horizontal translations. Now we know that if we take our original function, so here our original was just a sine bx that we studied last time, and we change this to bx minus c, then we changed inside of the parentheses, so it's a horizontal translation. And in which direction does it go? Well, it's a minus, so this translates to the right by c. So let's look at a quick example. Let's look at y equals 1/2 sine of 3x minus 2. Okay, so we'll compare it to 1/2 sine of 3x. And then, okay, so that's our original. Now we're going to compare it to 1/2 sine of 3x minus 2. And I'm going to take a different window here just so that we can see some more stuff. So let's go from sine of 6 pi to 6 pi, and we'll make our y min -2 and y max 2. Okay, so there's the graph of, that's too much, sorry. Let's just do -2 pi to 2 pi. That might show us a little bit of a better graph. So that's the original graph, 1/2 sine of 3x. Now when we bring the -2 in, it's shifted to the left, and we assume it's, or shifted to the right, and we assume it's shifted to the right by 2. So we've got these waves that are just translated from each other. So now we want to think about, let's just go back to our normal sine for a moment. So sine of x will look from -2 pi, -2 pi to 2 pi. And so here's our normal graph of sine. The way that we want to think about these translations is, after I've done the translation, where does this particular cycle go? The one that starts at 0 and ends at 2 pi. So if our cycle starts when we plug 0 in, then our new cycle should start when this whole thing is 0, because it's just like plugging 0 into the sine function. So the new cycle starts when bx minus c equals 0, i.e. when x equals c over b. All I did was solve this equation for x. And this is just because original function started a cycle when x equals 0. So if our original cycle ended a cycle, or our original graph ended a cycle at 2 pi, so that's 2 pi, then our new graph should end a cycle when what we're inputting equals 2 pi. So the cycle ends when bx minus c equals 2 pi. So in other words, we can solve this one for x as well. So maybe I'll show some more steps here. This is the same as bx equals 2 pi plus c, or in other words, when x equals 2 pi plus c over 2. So we can use this information to graph, and I just want to show you a quick example of how that works. So we want to sketch the function sine of x minus pi over 3. There's nothing multiplied in front, so the amplitude is 1. There's nothing in front of the x, so the period is still 2 pi. I've just done a shift to the right by pi over 3. So my cycle will start when x minus pi over 3 equals 0, or in other words, when x equals pi over 3, and end when x minus pi over 3 equals 2 pi, or in other words, when x equals 2 pi over 3, or 2 pi plus pi over 3. And that's the same as 6 pi over 3 plus pi over 3, which is the same as 7 pi over 3. So how do I use this to graph my function? Okay, so if I start to label here 0, maybe this is 2 pi, maybe this is pi, so then I have pi over 3, and 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3 is the same as 2 pi, 7 pi over 3 would be the next one. So I know that my cycle starts at pi over 3, so I'll put a point there. My cycle ends at 7 pi over 3, and it's sine. So I know that I'm going to start out by going up. I know my amplitude is 1, so I go up to 1 and negative 1. Instead of being 1 at pi, I'm going to be shifted over to the right by pi over 3. So everything just gets shifted. Oops, that's not right. At pi, we used to be at 0. So at 4 pi over 3, now I'm at 0. And so now I will graph this. So I have one cycle goes between pi over 3 and 7 pi over 3 instead of between 0 and 2 pi. And you can just continue to draw your sine curve because you know that after that one cycle, everything's just the same afterwards. So that's how we use this idea of finding the start and end in order to make a graph. In the next video, we're going to do a complicated example where we put all of this stuff together, the amplitude, period, and start and end point of a cycle in order to make a graph.